That's one small step for man, one giant leap for mankind.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello and welcome back to Your Place in the Cosmos. Now, we recently received some news from NASA of a technological breakthrough, so I'm not going to hang about. I'll get straight into it. Enjoy the video and hopefully I won't bore you to death. July the 31st, 2023. NASA's Mars Ascent Vehicle, or MAV, recently reached some major milestones in support of the Mars Sample Return Program. This video shows recent tests of the first and second stage solid rocket motors needed for the launch. Mars Sample Return will bring scientifically selected samples to Earth for study using the most sophisticated instrumentation around the world. This strategic partnership with ESA, the European Space Agency, features the first mission to return samples from another planet. The two-stage MAV rocket is an important part of the joint plan between NASA and ESA to bring scientifically selected Martian samples to Earth in the early 30s. Managed at NASA's Marshall Space Flight Center in Huntsville, Alabama, MAV is currently set to launch in June 2028, with the samples set to arrive on Earth in the early 30s. The Mars Sample Return Program is managed by NASA's JPL in Southern California. For the MAV to be successful, the team performs extensive testing, analysis and review of MAV's design and components. The vehicle will travel aboard the Sample Retrieval Lander during launch from Earth, a 2-year journey to Mars, and nearly a year of receiving samples collected by Perseverance, also known as Percy. After the sample transfer arm on the lander loads the samples from Perseverance into a sample container in the nose of the rocket, the MAV will launch from Mars into orbit around the planet, releasing the sample container for the Earth Return Orbiter to capture. The MAV launch will be accomplished using two solid rocket motors, SRM-1 and SRM-2. SRM-1 will propel MAV away from the red planet's surface, while SRM-2 will spin MAV's second stage to place the sample container in the correct Mars orbit, allowing the Earth Return Orbiter to find it. To test the solid rocket motor designs, the MAV team prepared development motors. This allowed the team to see how the motors will perform and if any adjustments should be made before they are built for the mission. The SRM-2 development motor was tested on March the 29th, 23 at the Northrop Grumman facility in Elkton, Maryland. Then SRM-1's development motor was tested on April the 7th at Edwards Air Force Base in California. SRM-1's test was conducted in a vacuum chamber that was cooled to -20 degrees or -4 degrees Fahrenheit, and allowed the team to also test the supersonic split-line nozzle, part of SRM-1's thrust vector control system.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Gimbaling solid rocket motor nozzles are designed in a way that can handle the extreme cold MAV will experience, so the Northrop Grumman team had to come up with something that could. A state-of-the-art trapped ball nozzle featuring a supersonic split line. After testing and disassembling the SRM-1 development motor, analysis showed the team's ingenuity proved successful. This test demonstrates our nation has the capability to develop a launch vehicle that can successfully be lightweight enough to get to Mars and robust enough to put a set of samples into orbit to bring back to Earth, said MAV propulsion manager Benjamin Davis at NASA's Marshall Space Flight Center in Huntsville, Alabama. The hardware is telling us that our technology is ready to proceed with development. In fact, the supersonic split-line nozzle has achieved the 6th of 9 technology readiness levels, known as TRL6, developed by NASA. TRL-1 is the starting point at which there is just an idea for a new technology, while TRL-9 means the technology has been developed, tested and successfully used for an in-space mission. Davis said the supersonic split-line nozzle achieved TRL-6 through vacuum bench testing and full-scale hot-fire testing in April. Results are being independently evaluated and will be confirmed in August. The supersonic split-line nozzle will also undergo qualification testing to make sure it can handle the intense shaking and vibration of launch, the near vacuum of space, and the extreme heat and cold expected during MAV's trip. In addition to motor testing, the MAV team recently conducted its preliminary design review, which was a 4-day, in-depth review of MAV's overall design. Mars Ascent Vehicle project manager Stephen Gaddis said MAV passed that review, which means the team can now focus on continuing to improve MAV before its critical design review next summer. NASA Marshall is designing, building and testing MAV along with the project's 2 primary contractors, Lockheed Martin Space and Northrop Grumman. Lockheed Martin Space is the overall system integrator and provides multiple subsystems, and Northrop Grumman provides the first stage and second stage main propulsion systems. The Mars Sample Return Program is managed by NASA's Jet Propulsion Lab, JPL, in Southern California.
That's one small step for man, one giant leap for man.